Well, good afternoon or evening, everyone. We just had a nice study session in the cafeteria. A bunch of the trigonometry students were there, so it was good. I'm all fired up to do a little review for you. So I'm going to go kind of fast and do some of the old topics real quick with not actually work any examples, but just talk about things to be careful for, some danger Will Robinson moments maybe. And then I think I'm going to do one clarification for 12-3. I think 12.1 and 12.2 are pretty accessible vectors and vector addition. I feel like you've got that down. But some of the parametrics, maybe we need some clarification. So that's the plan. Here we go. First off, when you're doing sine, cosine, or tangent of anything, make sure you take the sine or cosine or tangent of an angle and realize that that produces a ratio. And when you take the arc sine or arc cosine or arc tangent of a ratio, that produces an angle. And then you'll be okay if you just really keep that in mind. Sometimes we get that mixed up and we try to take the, we try to take the sine of some angle and we think, oh, that's a ratio, but it's not. That might be an angle in radians. And we get goofed up. Don't do it. Don't do it. Um, we're fine. That's an angle in radians. It's not a ratio. It produces a ratio. Okay? So just keep those straight. All right. Make sure you bring your unit circle and are comfortable with that. Maybe reviewing some of those major angles. Pi over 4, pi over 6, pi over 3, and are just totally comfortable with the unit circle. Bring unit circle. Okay, 3, we're going to have sectors of circles, and that's no big deal. Just remember that your arc length or radius can be used to find the circle itself or the area of the sector. It doesn't matter. But just be a little careful. Remember that different formulas for degrees versus radians. Be really careful there and know which mode you're in and make sure the formula matches which mode you're in. We're going to have amplitude, period, phase shift, horizontal shift, vertical shift, all of that stuff. But I think we've been through that quite a bit. There'll be lots of simplifications of, crazy expressions, cosecant. Messed that up. Cosecant theta times secant theta times sine theta, all those crazy things. Oftentimes, not always, but oftentimes, you simply want to, I think the first thing to try is express every term using sine and cosine. I think that's a good plan. Express every term using sine and cosine. It doesn't always work, but I don't know, 80% of the time probably it works. So that's a good approach. We will be doing lots of stuff on this test with the laws of sines. And just realize you use laws of sines when you know two opposites plus one other. And I guess by that I'm saying if you have some kind of funky, weird triangle and you know some angle, and if you know the length of the opposite side, and then you know one of anything else, anything, if you know this angle, if you know this distance, just one of anything, if you know this angle, or if you know this distance, anything else in addition to these two, then you use the law of sines. The law of cosines, we use that when you know two sides and the included angle. Or if you know three sides. They work both cases when you know two sides, the included angle, or you know three sides. So that's a situation. The most common is when you have, and you know this angle is 35 degrees, and you know this distance is whatever. And then say we have two sides and the angle that's sandwiched or included between those two sides. Then you're good to go with law of cosines. Or the other option is when you know the three sides, and then that allows you to find the missing angle. And just remember, if you know three sides, you're going to be finding the angle that is opposite one of those sides. So be a little bit careful the way you set it up. Okay. All right. Next up, we have double angle, half angle, all that stuff. I don't know what number I'm on. Double angle, half angle, tangent formulas. Just review all of those and you'll be in good shape. Copy them into your notes from those little shaded boxes they have in the book, and you'll be fine there. I'm not worried about you all there. We're definitely going to have some complex expressions with the imaginary axis and the real axis. That is the ugliest R I've ever done. And the real axis. Definitely have those. Don't freak out. You know, you'll have stuff like -2 plus 3i. It's not a big deal. This one comes first. There's -2. 3i is still up. It's just up in the I direction. Okay. So that gives us one of those guys there. And then you can convert that to polar if you want to, just r theta. I don't think I need to go through that. But just remember, in this case, you're going to get r cis theta is the only difference because of this I. R cosine and R I sine. Not a huge deal. Okay, moving on. Okay, I think we're 10 minutes in, so I should start this example so as not to bore you. Let's do parametric. In class today, a few of you had that parametric. A few of you had the panicked look in your eye about parametrics. And I think it's just that they seem a little bit foreign. And it's not that they're bad. It's not that the math is tough. It's just terminology. And again, it's that language thing and being comfortable with that. So let's come up with an example. So let's say that a particle at time t equals 0 is at position 3, -1, and at time t equals 2 is at, I don't know, 5, 5. Okay. And let's find out a few things about this. Find velocity, of course, we're going to do that. Speed. And write parametric equations. Okay, so that should be fine. So, yeah, we can do that. Remember in our book, we have, maybe we need a pleasant green here. What about? I think we're okay. Remember in our book, we were given xy, position anywhere, is equal to x sub 0, y sub 0, plus t times ab. And at first that looks a little scary, but really it's not. Once again, you're just drawing a triangle. Let's draw a triangle. So if we have the origin here, 0, 0. Okay, and it said start at 3, 1. So we go over 1, 2, 3. We go up 1. There's our starting position. And then that's at time t equals 0. Then at time t equals 2, it was at 5, 5. So that's just another couple there. And another few more there. 1, 2, 3, 4, 5. So it's at 5, 5. So this is our xy here. So that's 5, 5 equals, and then we have our starting position here. This is our x sub 0, y sub 0. So that's 3, -1, plus t, a comma b. And this is going to be our velocity. Okay? And that's what we can find. Now, one thing they don't really point out massively in the book is that if we've got an unknown here, you can just subtract things. You know, you can subtract this x sub 0, y sub 0 from both sides of the equation, and you're left with this when you're trying to solve it. I felt like they didn't point that out quite clearly enough. So let's do that. 5, 5 minus 3, -1. Notice I just subtracted 3, -1 from both sides. Yeah. So 5, 5 minus 3, -1 equals t times ab. Okay, so then we can say, okay, let's not mix apples and oranges. 5 minus 3 is 2. and 5 minus -1. Watch your signs. When bad things happen to bad people, that's good. Okay, 5 there, that's 6 equals T A B. Okay, so far so good. Now, check this out. This T exists outside of the parentheses. So think of it like, okay, I'm just going to factor out what's common. And what's common, the greatest common factor is a 2 for both cases. 2 times 1, 3 equals T A B. And we know that's true because I cheated a little bit. I knew up here this was for times T equals 2. So that's how I knew to do that. But you could have remembered that time equaled 2 seconds for 5. Okay? And that would have been the 2 right there. So now we know that T equals 2. T equals 2 seconds. And velocity equals 1,3. And I know you're not used to seeing velocity expressed like that. You're used to velocity being like north 27 degrees. But see, that's more of a polar expression. This is a rectangular expression for velocity. And it works. Okay? This is 1, 3 for every second. In fact, maybe I should get that 2 out of there because that might confuse you because that was for 1 second. For 2 seconds, it was at 2.6. Okay, so we got velocity there. We're done with that. That was one of the things we were going to get. And then we were going to get speed. Well, again, think of this because velocity has direction. Think of it like on your unit circle or whatever, just any situation like this. We can say, okay, if I go over 1 and I go up 3, that vector there has direction and magnitude. And the direction is like the angle, and the magnitude is simply the radius, or in this case, the hypotenuse. So let's find that. Speed equals the absolute value of velocity. It doesn't have direction, only magnitude. And so in this case, it equals the square root of 1 squared plus 3 squared. Look familiar? Yeah, good old Pythagorean theorem. So speed equals the square root of, what is that? That's the square root of 10. And I don't think we can reduce that, so it's just the square root of 10 units. But realize that is just the radius. There's no direction. You can go any direction you want to. And that's speed. Okay. I'm going to even write that in. Square root of 10. Okay, so we got velocity, we got speed. Now all we have to do to be finished with this thing is write a parametric equation, and then we'll get out of here. And you can go study. Yippee skippy, right? Okay, so parametric. So we know from before that xy equals x sub 0, y sub 0 plus t times AB. Oh, I lost my good pen. That's a general form, and it's in the book. Okay, in our case, we know that xy equals x sub 0, that was 3, -1, y sub 0, plus t times 1, 3. 1, 3 is our velocity. And so now we can distribute that 1 and 3, and we can say xy equals 3, negative 1, plus 1t, comma, 3t. And so this 3 here is x, this 1t is x, this negative 1 is y, and this 3t is y. So we can just combine these two. That goes with that, that goes with that. And so we can say then, and really, x goes there. I lost my y. I should have done that for y. I'm going to move that over through the magic of the symposium. I'm going to move that over. X is there, y is there. That's better. And so now we can say x equals 3. I got my 3 plus 1t, or just t, and y equals, it's not so bad, negative 1 plus 3t. And there's my parametric equation. See? You can do it. Okay, we're at 21 minutes, which is pretty long, longer than I wanted to go for, but we are done. Thanks for listening, and please ask questions tomorrow if you have any. Good night.